mainly about the challenges and this perfect introduction I had to what I think is, or will be the main challenge in the next few years. Maybe first of all, a few words about me. So I've also been making my mistakes in learning testing and hopefully learned a little bit the last 25 years. So in this case, it's very important to use the right English phrase. I have been making my mistakes, not I did make my mistakes. So I hope there's a lot to learn in the next 50 years, as you mentioned as well about that. So in environments, and this is a little bit why I have the advantage to have a lot of views on these testing topics in environments you would not consider be a testing topic. Also, as a researcher, as a physicist, I'm a physicist in times where I even did not know that what I did was called testing, and that testing is a necessary thing. But also some experience over the last 15 years in industrial environments. So I skip the current topic a little bit. So in the conference agenda, you see the title, A Phantom Menace. You not see the title, Digital Transformation, but we heard a little bit from the audience topics like artificial intelligence, self-learning, like cloud, and so on. For me, this all can be combined under this, let's say, comprehensive title, Digital Transformation. So, and it's intentionally that the first title is Phantom Menace. Who of you has seen the Star Wars Episode 1 movies? It's quite a lot, so I do not really have to explain about that. I think with this topic of digital transformation, and this is what I want to show a little bit in the next half an hour, is in a similar stage like we had in episode 1 of Star Wars, that was called A Phantom Menace. So we have this young Anakin Skywalker that is just quite rising from his village where he was born and discovering the world, and does not know if he wants to go to the dark side or the lighter side of the Force. We are at the first step in this topic of digital transformation, and I'm also the answers and the discussion we had on the first talk convinced me that this is the case. There's a lot of uncertainty in loads of the topics that altogether make this digital transformation. So this is the reason. First of all, we are approaching Halloween, so I would like to give you some kind of Halloween slideshow. What, from my point of view, are the most critical topics that we have to take care about in the next steps in digital transformation. My thesis is that there will major paradigm changes that will rapidly, and with rapidly I do not mean 5 years, I mean the scale of years, and will significantly, really significantly impact the whole ecosystem of IT, not only IT, of the systems we are developing in all the domains, be that finance, be that automotive, be that avionics, be that whatever. What do I mean with that? Okay, so I think you can focus on 4 main perspectives that make up the challenges that we will have to face in the next years in rapid steps of 1 year, but it will not be the end, and it will not be the solution in 1 year. It only will be the beginning. And coming back to Anakin Skywalker, then we hope that it's not ending like the episode 3, where Anakin completely turned to the dark side. So first of all, what I think is a very important thing is that there is a huge integration of consumer and business-driven requirements in a way that we do not know now. So yeah, to depict it a little bit, we currently have a society that transforms in using IT, in using software-based systems and so on. You're used to do everything, at least by parts, with this, with your wearable. Wearables are new, although not yet that established, as some of the vendors would have liked to. And we are coming out of a world of IT systems that are huge, complex systems that have borders. So the usage will be different. The usage, for example, of systems ruling factories, ruling agricultural processes and so on, will have more and more combination to what the user of current IT is used to apply. So this also means when you have, I have a colleague who always tells about his 15-year-old daughter, when she installs something wherever, and that's not sexy enough, within the first 5 seconds, the program is swept away. And this will also enter all the industrial topics. The second thing, there are, you know that hardware and software platforms become more and more heterogeneous. That's nothing new. That's nothing new, but you have very fast rising number and exploding number of variants. You only have to think of your smartphones. So it's not only about the hardware, it's not only about the operating system, it's about all the apps you have installed on your smartphone that make up the complexity, and at the end, that make up the whole thing you have to cover with your tests. The third thing is this heterogeneous landscape of IT, of systems, is built up from an increasing number of smart objects. Is built up from an increasing number of smart objects. What do you mean? Who of you has ever heard about smart objects? Not so many people. Almost raise up your hands. I can't believe that. 1, 2, 3. Only a few of you. Smart objects means, so I try if that works. Perfect. Smart object means that the components that are the components of your system are, let's say, a kind of acting software. They more and more get their own will. The brake in your car gets its own will. Maybe your fridge gets its own will because you are running out of milk and the fridge is ordering milk from the next supermarket or whatever. And you see that in a lot of domains and topics that are uprising now, also somehow kind of buzzwords. Of course, I could present you a list of 50 if I want to, but this is kind of the future. You have large environments like a factory, a smart factory, where all the components, beginning from the sensors and the actors at the bottom line of the automation process, are connected at the end, maybe also to your smartphone or the smartphone of the operator that has to have knowledge if everything works fine in the automation process or if there is a problem and he or she has to react. So the crucial thing is that all those components get more and more of an own will, of an own possibility to act on the scene. And the fourth thing is all this happens in a big complex interconnection with unpredictable, and this is what I meant a few minutes before, with an unpredictable process of the connectivity setup. You have connections that will be established and then switched off within seconds over the whole platform of your objects. So just to depict that, maybe your car also talks with your fridge because it is on the same hub of data transmission, not depending if there are different, of course, buses and so on that are connecting. But they are on the same hub of data connection because all that works personalized by you. It's your car, it's your fridge. You have maybe, not now, but in the brief future, you have your, let's say, life book where you manage your car with, where you manage your smart home with, and maybe where you also have some possibility to do home office and manage the automation process of manufacturing a car in your company or things like that. So, and this exactly is what happens. I mean, I could talk a lot about what are the other domains of these smart devices, of these smart components. The smart home can be combined to something that people call smart city, where you can, let's say, combine your personal activities also with the things that are going on in the city, to go to a cinema, to go wherever, to see if there's a traffic jam while going to the cinema, to see that from the infotainment system of your car, to order another movie because you see that you will not make it to the start of the movie, and so on. All, of course, based on loads of data. We heard about the big data problem, challenge, whatever. Smart data, there's open data, and so on. So just give you a scenario. The scenario is that your fridge discovers that you're running out of milk, or, okay, another example, you're running out of butter, and sends its data to this connection of this complete network. And this is personalized by you, and the fridge can send this data to the brakes of your car as well. So, okay, I'm coming from Germany. There you can drive 220 if you want to. So imagine you're driving 220, and for some reason, this connection that is opened for a few seconds influences the brakes to make to try to make a full stop at the highway with 220 kilometers. That's one single small example of what could happen. So this all with these fast dynamics reminds me a little bit of the brain, here indicated by some neurons you see. And the brain means that there are dynamics that can rise that we do not understand so far. Or so to say, we do not really understand so far what can happen. Maybe just to give you a slightly different example, who of you has heard about Arabic Spring? All of you will have heard about that. That's when the Arabic countries turned some political issues, but not only one country, but 5 or 6 countries at the same time. This was made possible via the internet, because there were a lot of connections to enable information flow. What are they doing there? What should we do? And so on, with high dynamics. Without that, I doubt that this Arabic Spring would have happened the way it did. And we will have the same thing. This is the Internet of people. And we will have the same thing now with the Internet of Things. meaning that those dynamics also involve all the components in our systems down to the actors and the sensors. And that, from my point of view, is the big challenge. So how can you tackle those challenges? I think there are two, let's say, main topics you have to address. The first topic is transformation of the quality aspects you take care of as tester. Now, of course, I'm coming to the fact of testing. So who of you is in the testing scene for, let's say, more than 15 years? Also just a few. More than 10 years? More than 5 years? Okay. So maybe then the guys who are longer there know it, that testing for quite some time only was a functional stuff. So you had some requirements, and you had to look if those requirements can be verified, validated, whatever. In the past 5 years, 10 years, there was also came a little bit those non-functional topics, like you all know, performance, safety, usability, things like that. But still, those topics are not to 100% in the tester's mindset. Performance, okay. Usability, I doubt a little bit that in the whole industry, the effort is laid on usability as it should be. But those are all quality aspects that are not so well established, but that are well known. We will also, with this IoT stuff, with those challenges I showed you, we will also have to find quality aspects and focus on those quality aspects that we maybe even do not know yet, or at least that are, let's say, new for us as testers, and that are not sufficiently covered by standards, and that are not sufficiently covered by skills in the industry to manage with those quality aspects. For example, topics like privacy, gamification is a topic, and so on and so on. So quality aspects, the focus on quality aspects has to change. The second thing is you have to transform, you have to change with this digital transformation also the approach to the topic of quality. Okay, the things you see here are well known. I think, of course, you have to improve process automation, and with process automation I also mean test automation, automation of the test case generation, maybe by model-based testing, and secondly, you have to provide, to foster the topic of quality, you have to provide the adequate architectural framework, in this case for those smart objects, and I claim that this adequate architectural framework does not yet exist so far. It's very, very important. So meaning that quality does not start with testing, but quality starts with the architecture that guarantees some of the quality aspects. And you also, and this is very important for me, have to deliver comprehensive standards. It's a complex and a heterogeneous topic, and adequate standards to manage those questions, those Star Wars challenges I mentioned before, including a rise of the awareness that those challenges are there. I doubt that I doubt that the industry is aware enough and ready to face those challenges, including a shift left, not only a shift left in testing, but a shift left also in this topic, provide the adequate architectural framework, so do something that I would call quality engineering. Not begin with the testing, begin with the engineering to supply quality. So we see those challenges, and now I come to the specific ISTQB topic. How could ISTQB help, or how could the community and network and knowledge sharing? It's not only about ISTQB help here. So, of course, by the way, just the question, who of you does know ISTQB? Who of you does not know ISTQB? Okay, no one. So that's good. So the schemes provided by ISTQB help, of course, to provide those basic skills that are needed. They help to provide a common glossary, and that's a very, very important thing. So when I remember from my point of view, success story of the certified tester, who knows the certified tester? Who does not know the certified tester? Okay, perfect as well, almost perfect as well. Certified tester is the worldwide most important training scheme, independent training scheme for software quality. When that, for me, began 15 years ago, there was large uncertainty about the glossary. So if you tell something about test management, one of the guys understood something like testing as a whole, and the others understood that what you now understand as test management. And by the years, this took some year. A certification like that as a glossary brought in a common language that now really has improved the way people can communicate, can share about testing and quality topics. And this standardization, and it is a standardization, not only ETSI, for example, provides standardization, they do it on the technical framework. Those training schemes do it on a skill framework. Those standardizations provide guidance at last, and with this reduce the uncertainty that still is existing, and I hope I could have made you a little bit uncertain with the first part of my presentation as well. So just to give you a few examples how ISTQB tackles the current and existing changes. I can't slow down many more. So this is what you also find in the internet, the latest architecture of the ISTQB schemes that includes a lot of the topics that are part of what I'm talking about. Agile topics, of course. Agile topics have a lot to do with including process automation, with including the need to foster test automation. And there will be, this is in development within the ISTQB scheme, also concrete courses that address test automation in the Agile domain. But there also will, or there are, and there will be specialist modules that address those quality aspects that get more and more important, like security testing still yet existing, and the model-based tester I had the honor and the pleasure to develop with a group within ISTQB, also including Stefan Schulz, you see over there. And you have some of the specialist modules still in work, like test automation on a specialist level, like testing in the automotive domain, like usability testing. Skipping all the details of that, maybe coming to one thing I consider very important. what you also should do, and what is growing more and more important, is to, let's say, use your community, work together in your community to reduce the confusion, to be able to provide topics like that. This is an example that is currently under work by the German testing board in combination with the ISTQB. That is my association. I earn the money for life for. That is addressing exactly this topic of quality engineering for the Internet of Things. And that's, from my point of view, one of the two main messages, not only addressing the testing topics, but in this case, we focus on quality engineering as well. So, of course, giving a first layout of the content of this course that will come includes things like the context, in this case means the architectural context of IoT. Still some work to do to, let's say, make up our minds of what is yet there, like RAMI 4.0, there are standard architectures for that and so on, and what could come. But as you see, we do not only do the testing, and this is will be a course for the quality guys. We do not only focus on the testing. We here call analytic quality assurance. Analytic, since we do something on the finished product or finished components of the product, we also have a big part of this course laid on constructive quality assurance. Exactly meaning this topic of quality engineering we have seen in the slides before. Sometimes it works, sometimes it does not. I do. Okay, so then I will not return to the slides before. Just this is really what I want to point out. We know a lot about these testing topics. The discussions the last few years in the context of Agile also drive us a little bit into the topic of the shift left, so to test as early as possible, if you can do that. But this is something that even goes one step beyond, meaning to take care about quality in setting up your standards and architectures for the setup. So I hope, now I'm stuck. So not to exceed my time that I have won due to the previous talk too much, coming to some kind of outlook and conclusion. So especially in the context of the test skills framework, and this is what I focus on that. I have not explained what of the development or testing methods should be developed, but how it can be transferred to the people as skills. So what is important from my point of view, and although this is included in, let's say, the ISTQB portfolio, this is only my private view on this. So we have to take care about the mindset and content. As I said, focus on quality engineering instead of doing everything at the end. So focus on new and further quality aspects. There'll be loads, too much to present them here. That's of course always dependent in what area you are applying your quality assurance. So be aware that soft skills are very important. Soft skills somehow is the fuel that is driving quality in the development. And be aware also that there are rising standards for this topic. There's, for example, this skills framework for the information age is a kind of norm that is currently established regarding IT skills. From my point of view, very important is to bring those skills to the people in a more practical approach. It should not be a lecture. It should be, in the case of trainings, practical-based training, whatever that means in reality. Make a project, a small project in your 3-day course. And it means sustainable learning, meaning you carry something with you home from the training that you can, for example, work in your company with and improve in your company. And from my point of view, also very important is a configurable and flexible content for the skills you want to transfer, you want to bring to the people. So to explain you what I mean, back to the ISTQB scheme, that also is a private thing. So here you got the scheme with, let's say, pathways you can now go through. But why not? There's too much animation. I shouldn't have so much animation there. Okay. So why not going to some of those specific topics to later, now it comes, to later focus maybe, for example, on parts of those advanced topics like test management or test design. So what I mean is to cut all those topics into slices to be more configurable to apply what you really need to improve your skills. Just one thing is missing, what I did not talk about, and this will be in this context very important as well. That's really an open question. This is that one, people and society. So with the topics, you have an increasing demand to include political and social environments into the discussions and also into your quality assurance activities, and even coming to ethical questions. Give you the example of, a lot of you will have read about this Tesla that had a fatal accident a few months ago. So what about your autonomous car that has to take the decision, go right and kill 3 pedestrians, or go left and kill the driver? So in case of society, then an accident will happen, and then maybe it goes to the court. In case of the autonomous car, you have to decide in advance and give your car the algorithm what, in cases like that, it should do. And this will be a hard discussion, and this will even be a harder discussion in the context of quality and quality assurance. So let's see. I'm quite curious how this will evolve. Thank you.
Thank you. And now let's go for the Slido questions. So we have 4, so it's increasing.
Okay, how I see the biggest challenge regarding or considering the smart world. I mean, that's a really difficult question to answer, because the smart world comprises everything from home to automation to automotive to finance to healthcare. So there is not one solution. For example, if you are looking at topics like, let's say, finance or smart governance, where you can make your tax via the internet, things like that, there are definitely focus points on things like usability. If you regard autonomous driving, that goes much, much more to the core of hardware and software, of embedded that goes into domain-specific things. So there would be a lot to do, and there is, let's say, a big variance of things that we have to address here. And of course, the things that I showed here first can only be the first step into this. And not only can only be the first step, we need to work all together as a community, and this is also one of the things that I would issue here as a message, to really manage this large variety of things we have to provide to cope with that challenges. Okay, the question is if it will be too expensive then, with all these variability topics and so on, to test all that. It will be like it always is. The costs will be adapted to the business, so those things will come. The costs of developing them are quite affordable. They are not exceeding what you usually have in what you usually are used for development of the systems you currently have. And so the main issue, of course, then would rather be the risk-based approach, or how to select the appropriate tests that first can be afforded, of course, and secondly, that addresses all the product risks sufficiently to supply the knowledge needed on the quality of what you do here. Okay, that's an interesting question. So what do we need? Do we need the specialists or do we need the generalists? There is, let's say, a current discussion that says, we need both. They call it the T-shaped man, or the long man, or whatever that name is. What means, and this is an experience that also comes out from agile topics as well. You, of course, in the current processes, thinking of agile, for example, in the current topics, need more a more general basic skill set than you maybe have needed in those waterfall projects that you, the 10 or 15 years guys know that, than you needed a lot of years ago. But of course, it is also important that you provide your special knowledge to be set on the special topics. A team always has a kind of split of the activities. Everybody has a focus point, and everybody should be generalist, but also have his own focus point. Removed in priority. So the next one, what type of tests is more important, manual or automatic ones? I think we have to do a lot to foster this test automation approach, because otherwise, in the context of more and more variance, in the context of the dynamics, we will not manage to really make the test sufficient to cover the aspects, even not the risk-based prioritized aspects, what we have to deal with. So automation must be improved in coverage. That's definitely my opinion, but there always should and will be manual testing, because with manual testing, you use the human brain that still is a little bit more flexible to react on complexity than any algorithm, from my point of view.